All right, we're looking at exponential function context and data modeling today. So sometimes you can't quite see the exponential growth pattern due to a vertical translation. But if you remove that vertical translation, maybe you can find it. So we're going to look at a couple of simple examples like this one here to begin with. What could we, if we take off a value from each one, we take f of x and we subtract something, we could either try adding 1 to it maybe, or taking off 1. Let me take off 1 for a little bit, see what that gives us. That's going to give us 6, 12, 24, 48. Can we see the pattern here? 98, yeah, 96. So with simple questions, sometimes you can just add or subtract a value. Now if I look at the difference between these two, sorry, the proportionality, it's 2, 2, 2, 2. So these are, each time we go up, we're multiplying by 2. That means that the function is going to be f of x is equal to, it's going to be 6 times 2 to the power of x plus 1. So I'm using this value here for that value. This value here is our, how much it's proportional by. Because we're subtracting 1 from f of x, rearrange that, then we just see f of x minus 1 is equal to 6 times 2 to the x. So rearranging to the side, it's going to be plus 1. You want to have a go at an example or two? Have a go at these two. I'll just pause the video a minute for you. All right, so for this one, we could take g of x. We could add 2 to it each time. It's going to give us 4, 12, 36. Can you see a pattern there? 108, 3, 2, 4. So this is times by 3. This is times by 3. Times by 3. So what's our function going to be? G of x plus 2 is equal to 4 times 3 to the x. So G of x is equal to 4 times 3 to the x minus 2. Oh, that's 63 is close to 64. 64 is always a good number, isn't it? Always a good number is 64. I'm going to guess for 64 there. So that would be h of x plus 1. 32, oh, I can see it there. 16, yeah, 8, 4. So h of x plus 1 is equal to 64 times, what's the proportionality here? Half. Would that be right as the answer? 64 times 2 to the minus x? Why have I put that minus sign in? Explain to the person next to you, quietly. Where did the half go?
So it's only correct to put it in half?
Yeah, it would. Isn't that neater, though? Isn't that neater?
I don't think so.
You could have a half as well, but you want to be used to equivalent forms, because one of the main things this topic is about is equivalent forms. All right, so make that a little bit bigger. There we go. So for 30 minutes, the number of fans inside a large sports stadium can be modeled exponentially. There are 47 people in the stadium 2 minutes after the doors open. There are 2,602 inside after 20 minutes. Use the data to write two equations to find the values of A and B. It's fairly straightforward, isn't it, that one? Jump into that one. So we got 47 is our Y value, or F of T. That's A times B to the, and our value of T when it's is 2. So firstly, I'm using this statement there, which is a coordinate point, 2, 47. Take that coordinate point and put it into the equation. We have another coordinate point there. This coordinate point is 20, 2602. So that gives us the equation 2602 is equal to A times B to the 20. I think that's all the question is asking us to do. Should we have a go at finding A and B here? I think so. How, algebraically, how would we solve this? Let me give people a minute to think. I'll take. Algebraically, have a look at that. How do you solve that? Yusuf, are we looking? How do you solve that for A and B?
When you divide A and B?
Sorry?
When you divide A on both sides? Or when you root out one square root?
Partly correct that. The idea of division and rooting is how we're going to get to our answers. So Gully was first. How are we going to solve this?
We can divide by each other. Then we get an equation of
Okay.
B.
Let me do that. So what he's saying is we're going to form a system of equations like this. Use this symbol to say that this is now a system of equations to be solved. And there's a few ways you can solve it. You can add equations together, subtract equations. One of the best ways for exponentials, for exponential functions, dividing one equation by another works well. So if you take that second equation and you divide it by the first, you're gonna simplify it quite a bit. So this implies that 2602 over 47 is equal to A times B to the 20 over A times B to the 2. Now that simplifies, not beautifully. This bit isn't an integer answer, so I'm just going to leave it at that. But the A's cancel. And then the B's simplify using the laws of indices. It'll be B to the power of what? It'll be B to the power of 18. So then the other thing that Yusuf suggested was rooting. He said square rooting, but he meant rooting, I hope, because this is the 18th root. So that would imply that B is equal to the 18th root of 2602 over 47. Get your calculator out, pop that in. Tell me what it is to three significant figures. Make sure you know how to do this on your calculator. Get your calculator out, pop that in. What do you get? Let me take a minute and like everybody to have a go at it. Everybody take your calculator out. Make sure you get this value. Three significant figures. Let me just pause a second. Where are we up to? So we get 1.25 on that one. If you're going to use this, use the exact value in any subsequent parts to the model. So we put the 1.25, we see an approximate, but if I was actually using this to make calculations, I might put the exact value in. So we need to find the value of A. That shouldn't be too hard, should it? We can use 47 equals A times, and we put in the exact value like that, squared. So let me just write that in an equivalent form. If I wanted to get rid of the 18th root and write it as an exponent, what would it be? 1 over 18, so 2 over 18? So it's 1 over 18, but that's going to simplify to 2602 over 47 to the 1 over 9. Why is it 1 over 9? 2 over 18. And then we can just find the value of A. So what would A equal? Do the calculation on your calculator. I won't come down and check this time. Do we get 30.1? Yeah? So our function f of t, roughly 30.1 times 1.25 to the x. All right, let's try the next one. Going to use a different technique for this one. So we are going to write two equations to find the values of a and b here. What would those equations be? Yep. 21.54 equals a times b to the power of 3 on our other equation.
3.62
to the power of 8. All right. So we can solve this using regression. Let me do a right. So what we want to do, let's have a look at another little technique we can use our calculator for this one. So on your calculator, press the on button like this. You come to the home screen, choose a new document. No, I don't want to save anything. Add a calculator. And we get like this. So then press the control button here, the red one, and then choose add document here. And we're going to choose to add a list or spreadsheet. We're going to label this X, and we're going to label this Y. We can put in our two values. So our X values are 3 and 8, and our Y values are 21.54 and 3.62. Type your data in like this.
So how do you do the spreadsheet?
Control, add page. Add page is above document on the top right side. And then number 4, list or spreadsheet. Are we ready? Everybody ready? All right, so next up, press Control and then left, and you'll move back to the calculator page. We choose menu. And what we want here on this one is statistics, stat calculations. So menu 6, 1, and we want to find exponential regression. There it is, A on mine. Pulls up a little dialog box for us. Click the right button. We want the X lists are X and our Y lists are Y. Note where it's going to save it. It's going to save it in F1. And then we can click OK, and it will store the equation for us. So we can see the values here now of what our equation is going to be. So we can see that it is going to be y equals, and we've got 62.8 times, I'll put that in a little bracket, 0.69999, so 0.700 to the power of x. That's our value. Okay.
The first one also counts as an equation. It says write two equations. The first one.
Yeah, there's two equations. All right, so our next example, the number of bacteria in a particular culture can be modeled by the exponential function given here. Let a of t equal a times b to the t be an equivalent expression for b of t. Find the value of b. All right, so what we've got here is we have it in base e. What is the value of e? Does anybody know? 2.71? 2.7. Let's find it on your calculator. So look at your calculator. If you click on your calculator, you have pi on the bottom left. Can you see the pi button? Click on pi, scroll across, you can find E, press enter, or press control enter, and it will give you the value. If you take your calculator out of float 3 and put it into float, you'll see a full decimal expansion. This is Euler's number, 2.71828182846. This number comes up more often in math than pi. This is a very important number in mathematics. Euler's number.
So why do they focus on pi so much?
Because pi is easier to access in geometry earlier on in mathematics. And this comes from rates of change. So it comes from rates of change. So if you have an exponential function in base e, it is increasing at the same rate that its rate of change function is increasing. So it would look the same. So the function and the rate of change function look the same. That's a special number on that one.
So do you remember the letter E to be decimal place?
So let's have a go at doing this now. We need to let a of t be in this form. So that means that in order to find the answer for a, we need b is going to equal e to the 0.31, like this. So we type this into our calculator. You can actually find e to the x, which will be a bit quicker, just to the left of the 1. So find the e to the x, 0.31, and we get b is approximately equal to 1.36. So b is actually equal to e to the 0.31, but approximately 1.36.
So if it says round to the 3, whatever, 3 decimals?
Significant figures I usually use.
Yeah, so would I put the 0 or no?
Yes. But this isn't... Are you referring to this number here?
Yeah, like for example.
That number is in two significant figures.
Yeah.
Significant figures are counted from the first non-zero digit.
Okay.
So from the left, you find the first non-zero digit, and you count across, and that's how many significant figures there are.
Even if it's 0, I still put it.
Definitely, yeah. But what I'm saying is the preceding zeros do not count in the significant figure.
Oh.
What about 17? Just leave it?
Well, I'm just answering the question at the moment. So the question is, find the value of b. And that's what I did. I haven't read the next question yet. So b, find the average rate of change of b of t over the interval from 1 to 7. So we need our average rate of change formula. Average rate of change is equal to y2 minus y1 over x2 minus x1. That means we need, we're going to use b of 7 minus b of 1 over 7 minus 1. Let's do that on the calculator. Alright, so let me show you how I'd make this calculation on my calculator. We're given the model here. So I'm going to go to the calculator. I'm going to press Control, add a page. I'm going to add a graph. In the graph, noticing I'm on f of 2. f2 is the function I'm entering it into. I do 17 times, and then I press e to the 0.31x. I transpose t for x, get my function there. So then I press Control to the left and move back to this page. What I want is Control divide, I get a quotient, and I'm just going to type this in. So b is now f2. So we need f2 of 7 minus, and I press the variable button here, f2 of 1. Sorry, I missed the minus sign. Over 7 minus 1, which is 6. Enter. So I get, for that one, this is going to equal 21.0. 21.0.
Wait, so how does it know F2 again? You put it in or what?
I typed it in, didn't I? So let me show you what I did there again. So what I do is I start by adding a graph page, Control add a page, I add a graph page, and now I'm on F3, and I type my function in here. So I typed it in there on F2. So then when I come back to here, if you press this variable button, you can access the other functions you've made. This is the regression one we made earlier if we wanted to evaluate.
How do you find the value? Where's the variable button? Oh.
The variable button is here. Sorry, boys. So f2 of 7 is this value. We're subtracting f2 of 1, this value. Those are the two values. We're finding the rate of those are the two y values we want. And then we found our rate of change. Okay, continuing on. Example 5. After 50 deer are introduced to a large wooded area, the population of deer in the wooded area can be modeled by the function, where t is the number of years since the deer were first introduced into the wooded area. The population in deer increased by 13% each year. Find the values of a and b and use these to write the function d of t. So we've got a few numbers given here. One of the first numbers given to us is 50 deer at the beginning. What is that value? That value is a. It's our initial value, isn't it? A, if you remember, a is always the initial value. So we're going to get d of t is equal to 50 times What other numbers do we get given? We get given 13% each year.
1.13.
So how do we turn that into our B value? Jude?
You add 1, so you add the percentage into a decimal and you add that to 1 because you are timesing the original, the initial amount of 50 by 1 plus 13%, so
Yep.
0.
Yep, so Jude is correct. It's increasing, so we're adding 13% to 1. 1 is 100%. So adding 13% to 1 gives us 1.13 to the x.
To the t.
Oh, to the t, thank you. To the t. According to the model found in part A, what is the population of deer after 6 years? So we're finding d of 6. Put it into your calculator, what do we get? Calculate it, what do we get?
104.
We get 104. Find the equivalent expression for d of t where t is measured in months instead of years.
Is it t over 12?
I like. So, d of t is equal to 50 times 1.13 t over 12. I took a second to answer you to check that you were right, and I looked up and I visualized it. And I basically asked myself, if I put in 12 months, what do I get? And I see sort of 12 divided by 12 is 1, and I say, okay, that's the same answer that I would have got if I put in 1 year into the original formula. I'm like, yep, this is the right formula. Just little techniques like that to double check or verify you're using the right math. Simple and easy. Find the equivalent expression t in months instead of years. Yep, that's that one. That's the same question. That's the end of the slides. Okay, that's it for today, everybody.